Couple minutes late, but it is Sunday and it's time for live coding. And today we're going to try and make an Asteroids clone. I even made this little promo to help spread the word. So our goal is to make Asteroids in an hour, and I think this will be a lot of fun. Of course, the original Asteroids game was all vector graphics. The electron beam and the cathode ray tube was directly moved in lines to draw each of these shapes, which is pretty cool tech and something you don't see anymore. We don't have that. We have a raster display, but we're going to use sprites that have this little glow effect to kind of emulate what those old tube displays look like. And yeah, it'll be a good exercise in sprite-based game development. So I earlier in the week made this set of sprites. These are all transparent. And I also made a cutting guide that shows how big these things are, and will make it easier to pluck these sprites out of the sheet. So let's see, I'm going to open this up and we'll keep this handy. Let's see, where can I put this so that everybody can see it? I'll just kind of stick it down here, I guess. All right. And over here in Mini Micro, I've mounted the folder that contains all those things. And I did do a little sprite test yesterday. I hope nobody considers this cheating. Hey Seb, thanks for joining me. I posted this code to the Discord the other day, but I'll just show what it is. I wanted to see whether it was better to have to use the double resolution sprites and scale them down, or the single resolution sprites. And if I zoom in, maybe you can see the difference. The double resolution sprites just look a little bit smoother, as I expected. With the single resolution sprites, as they rotate, you can see some aliasing, even despite the glow, although the glow does hide a lot of evils. So we're going to go with the double resolution sprites scaled down. So I think the first thing I want to do is write some code to carve up my sprite sheet and pluck out all of these individual images. We have 3 different asteroid shapes in each of 3 different sizes. Then we have the ship with and without the thruster activated. And we have UFO. And then we have 2 bullets. This is the player's bullet and this is the UFO bullet, which is a little bit bigger. And I'll probably tint them as well, since I can. Of course, the original Asteroids game was not tinted because the display wasn't capable of that. In one of Atari's official later remakes, they tinted the UFO and its bullets red. So I'm going to do that, and I may also tint the ship and its bullets green, just because I think that'll look nice. So let's dig into it. Hey 3O, thank you for joining us. Okay, so right, this was the code that I used to test the 2 different sprite sheets. And actually, this wouldn't be a terrible starting point. Let's just get out of here, or actually we don't have to get out of here. We could use save as, if I hold the shift key and click save, and we'll call it Asteroids. Okay. So we're going to get the 2x sprite sheet. And then I just want to define images for all the different things. So we're going to have, let's put them all on a map. Images is a map. Images.ship equals this thing. So this is going over each of these little boxes here, 64. So I went over 0, 1, 2, 3, and then I took a 96 by 64 section of the image. And if I want images.ship thrusting, that'll be the same thing, only we'll go over a little bit further. We'll go over 64 times 3 plus 96. I'm being lazy and just letting Manuscript do the math for me here. Let's see, we need images.bullet. This one, I want to count from the right, actually. Let's see. Again, we could let Manuscript do the math for us. So we'll do sheet 2x.width minus 64. And this little sprite here is 32 by 32. And then we'll do the UFO bullet as well. Only this starts at width minus 32. So there's that. And let's cut out all this stuff and just test what we've got so far. Using the view command, I can say view images.ship, looks good. View images.ship thrusting, also looks fine. Images.bullet, and UFO bullet. Yep, so far so good. All right, let's grab our well, I guess we'll grab the UFO next. Sheet2x.getImage. Okay, I'm going to do sheet2x.width minus 96. And this one starts where? Here I actually have to count. Each of these little squares is 16, and we have 1, 2, 3, 4, 5. So 16 times 5, and then it's 96 by 80. Okay, now let's get the asteroids. And let's see, how do we want to store these? I'm thinking maybe in a two-dimensional array. So let's import list-util. And we'll say images dot, we'll call them rocks, because that's easier and shorter than asteroids. So the rocks is list.init2d 3 by 3, and we'll index by type and size, each 0 to 2. So now we can do for, let's see, for type in range 0 to 2, let's see, images.rocks, so type, and 0, let's see, should 0 be the big rocks or the little rocks? I think 0 should be the biggest rocks, so we'll add 1 to the type every time they break until we run out and break the tiniest rocks, and then no more appear. So 0 is these big ones, and we're going to go, let's see, 64 plus 96 is the y where these begin, and these are 160 by 160. So I could use, yeah, no, this is right. This is the big rock. Equals sheet2x dot get image. So the x is 0. No, it's not. It's 160 times type. That's what it is. And the y is 96 plus 64, and they're 160 by 160. Okay. Size 1 is these middle guys. They're 96 by 96. And they start just 64 up from the bottom. Oops. I'm editing the wrong thing. Doggone it. Totally skipped a line there. Okay. 96 wide each. All right, and then type 2 is these tiniest ones. They start at 64 times type and a y of 0. They're right on the bottom, and they're 64 by 64. Okay. So again, let's run and do some viewing. Let's view images.ufo, make sure we got that. Yep, let's view images. We're just going to spot check the rocks. So let's say type 0, size 0. Looks good. Type, how about type 1, size, well, we'll actually type 2, size 1, make sure we're getting it right. So you can't see where I'm pointing. Type 2 would be this one, size 1 should look like this. And then let's get this middle one here. This would be type 1, size 2. There it is. Okay, cool. So I think we're loading all our images properly. Time to start making animation. So in Asteroids, I'm assuming that everybody knows what Asteroids is. It's part of our culture. Super important game. There's a lot of stuff moving around constantly. So I think we're going to go with a pattern of every sprite having an update method, and then the main loop will just call update. And in fact, we can have other things that update too, like the background sound, that little bip boop heartbeat that I posted to Discord earlier today. That could be an updatable as well. So let's make the ship class first. I don't need more than one ship, so I'm not going to actually define a class. I'm just going to say ship is a new sprite, and its image, to start with anyway, is images.ship. Its scale is going to be 0.5. They're all going to have a scale of 0.5. So now I do feel like I should insert a subclass here. Okay, game sprite is a new sprite, and game sprite has a scale of 0.5. And then everything else can be a game sprite. And we can also give a default update method. Oops. I think I'm going to give it a DT, a delta time, which by default will do nothing. Okay, so now we don't need to say ship scale equals 0.5. We do need to position it, or let's give it a reset method actually. Ship.reset equals function, and that'll do self.x equals 480, self.y equals 320, that's right in the middle of the screen. Self.rotation equals 0, why not? Okay. And then we'll call that right off the bat. Actually, we should call it as part of the main loop setup, I guess. Board setup or something like that. Okay, we should do I'm going to have an init method as well. GameSprite.init equals function, because one thing every sprite has to do is push it onto the display list. So display for.sprites.push self. Okay. So after we define our ship class, we're going to ship.init, and that we only want to do once. We're not going to do it every time we reset the board. So I'm going to keep that up here. Let's test this much. Yep, there's our ship. I should put a clear method. Oh, I have clear. Yay. All right, great. So we can run that multiple times and we won't get multiple ships. Now, update. This is a fun bit. Of course, unless we actually call update, this isn't going to do anything, but that's okay. We'll get to that. A ship, like several other things, has a velocity. Bullets have a velocity. Rocks have a velocity. Maybe every game sprite has a velocity. I think that's pretty much true. So that means we can put more in our game sprite method. GameSprite class. So velocity x is how far it moves per second in the x direction. Vy is how far it moves in the y direction. And now our update method can actually do something useful for any game sprite. It can do self.x plus self.x plus self.vx times dt, y plus self.vy times dt. Ida, you made it. I'm so glad. You haven't missed much yet. We've just loaded the sprites, and now we're starting to define the code that makes them move. So everything has velocity. We apply the velocity times the time to update our position. And the only thing that a ship has to do that's different is update its velocity based on when you're thrusting. And I'm going to use the axis inputs. So let's see. Thrust equals key.axis vertical. And I don't want to let you, in the original game, you couldn't thrust backwards. If you push down, well, there was a hyperspace button, and a lot of times on a controller that's mapped to pushing down. I don't know if we'll get to hyperspace today. Probably not. So I'm just going to say if thrust is less than 0, then thrust equals 0. And then we can apply that to our velocity. Let's see. So let's do something like self.vx equals self.vx plus cosine of self.rotation. Of course, rotation is in degrees, and cosine and sine take radians. So let's do radians equals, what's this axis thing, Subnazi says? Well, good question. Key.axis accesses horizontal and vertical inputs that can come from the arrow keys or from WASD or from a gamepad. So I have this cool little Nintendo style gamepad that I will probably plug in and play with. And when I use the D-pad on this thing, that also is read by the key axis horizontal and key axis vertical. And if you had some other kind of gamepad or joystick, that would work as well. So it's a really handy way if you're doing any sort of game style inputs to get at axes and buttons. For the buttons, you have to check explicitly for the buttons. There is no clever mapping that would make, like this button on my gamepad equivalent to pressing the spacebar or something. But for the directional axes, there is. So that's what that's about. Yeah, controller's handy. It's a lot of fun to play with, especially if you're going to do a multiplayer game like Retro Robots, and you want two players to, do side-by-side couch co-op or competitive play. A lot easier than crowding around the keyboard. Okay, so radians is self.rotation times pi over 180. Now we can do cosine of radians. And then we need some kind of acceleration constant. So let's see, we'll just put it on the ship. Ship.acceleration equals, and I really don't know what's a good value here. We'll find it experimentally. This is in pixels per second per second. So times dt. So this is our velocity plus, oops, I should have said times the thrust. So times the component of the thrust in the horizontal direction times the time step. Converts that from acceleration to a speed, and we add it to Vx. Let's do the same for Vy. You can just plug that in and it would work in Mini Micro just like that. Yep, that's exactly what I mean. It's always fun to surprise somebody. Okay. And then let's just try this much first. Let's get this running. The other thing that the ship in Asteroids needs is a bit of friction. Velocity automatically decays towards 0 when you take your hands off the controls, which makes it much easier to play, but we're going to leave that out for now. Let's get an update loop going. Main loop. Let's see. I want to calculate a time step every time, so I need a last time, and then while true, and say, let's see, dt equals time minus last time, and then last time equals time, and then we can do for sp in display for.sprites sp.update with dt. I think that should do it. Save it, run it. Okay. Nothing. So, ship, let's p-print our ship. It does have a little bit of x velocity. It's just much too small. It's moving 1.8 pixels per second, and yeah, I didn't notice that at all. Also, I shouldn't be using horizontal. I should be using vertical. Oh, I am using vertical. Okay, that's good. So when I push up, that should be positive, and it should increase, but I think our acceleration just needs to be way higher. I don't know what's going on. I'm pushing. Oh, you know what? I know what's wrong. Now I've got kind of a respectable velocity, but I'm never calling the superclass update method, which is what makes the sprite actually move. So after we update our velocity, we need to do super.update dt. Did you try unplugging it and replugging it? Yes. Very good. Okay. So here's my little ship. It's moving, but man, it's sluggish. It has weak little thrusters. So let's increase this even further. In fact, I'm going to add 2 zeros. Oh, it's still painfully slow. I'm surprised it's still so slow. Makes me wonder if I've done something wrong. Yeah, our x velocity is only 11 right now. Even though we're adding 10,000 times the time step. Our time step is pretty small, sure, but 10,000 times the time step is 0.3. Oh yeah, that's not much. Okay. We really need that much. 7. I mean, come on. It seems like this is getting ridiculous. What am I doing wrong here? This is supposed to be the easy part. The radians should be 1, right? Cosine of 0 is 1. Times the thrust, which would be 1, I think. Let's check this out. Wait, print t.axis horizontal. And I'm going to hold the at vertical. Yep, it's 1. Are you using acceleration's value? No. So that's why it doesn't seem to matter what value this is. Okay, thank you. The more people are watching, the dumber I get. Okay, thrust times acceleration times time step. Of course. Okay, this will work a lot better, I bet. Yeah, there we go. Okay, that's still not quite zippy enough. And oh yeah, we have to deal with wrapping around as well. So let's make this about 1,000. And let's have this thing do the wraparound effect that Asteroids is pretty famous for. So let's see, I don't want to do it as soon as we cross the edge. I want to give a little bit of margin on either side, top and bottom. So we'll say if self.x is greater than 100. The biggest asteroids are 160 across, which means 80. So we'll say 80. If it's bigger than, let's see, what is 960 plus 80? 1040. Then self.x equals minus 80. And I guess we'll do this with a proper else if structure. Self.x is less than minus 80 then. Self.x equals 1040. And if. And then we'll do something similar for y. 640 plus 80 would be 720. My math is right. If it's less than minus 80 then, self.y equals 720. Okay, so that should get us wrap around. Oh yeah, that's a zippy ship. Better. Okay. Now let's make it so we can turn. Don't tell Joe. Yeah, you guys should tell me these things faster so I don't waste so much time on silly mistakes. Okay, right. So the other thing is turn equals t.axis horizontal. And again, I'm going to introduce a constant, which maybe I'll actually remember to use this time. Ship.turn rate equals, it's not actually the turn rate. No, it is. It's exactly the turn rate. So how fast can you turn around? I'm thinking about twice per second, which would be 720 degrees per second. So self.rotation equals self.rotation plus turn times, turn rate times dt. And you know, if we did this before we applied the thrust, it might be just a hair more responsive. Okay, let's try this. So left, right, oops, I got them backwards. When I push left, it's turning right. That's because angles go counterclockwise. So let's say minus. Okay, there we go. Nice. Okay, now I really need that friction because you can see me trying to stop the ship. It's really hard. I'm just making things worse. Hey, okay, almost got it, but now let's add friction. Let's see, I think that the way I'm going to simulate friction is with math-util. I'm just going to do move towards. So let's see. Math-util has this handy move towards function. Move towards xy, that's it. This is pretty small. Let me see if I can embiggen this. Okay. So you give it the thing that has x and y properties, and you give it a target x and y, and how much you want it to move. So we can do that. Actually, I'll just use move towards separately on the x and the y. Is that the same thing? Let me think about that. No, it's not the same thing. All right, unfortunately, it's the velocity, not the position. Oh, chat covers that up. I'm sorry. Let me bring that back. So this is math-util. This is the function I'm thinking about. Yeah, but it's the velocity that needs to go to 0. So because I've called them Vx and Vy, I can't directly use that. And that annoys me. So I'm going to change this to velocity. Maybe we'll just call it V. X and Y. And in the init, we will initialize that. Self.v equals x 0 and y 0. Okay, some people might be wondering, why did you do this in self.init instead of just doing it right up here? The reason is, GameSprite, the base class, would have just one copy of this mutable map if I put it up here. And all of the sprites would share it, and so they would all have to have the same velocity. And that's not what we want. We want them to each have their own velocity, and so I need to create a new map for each game sprite, and the init method is a good place to do that. And so now we're just going to say v.x and v.y. And down here we'll do something similar. So that should all still work, but now I can do math-utils.move towards self.v. I need a 0, 0. Let me make that as a constant somewhere. Okay. Move towards 0, 0. And self.deceleration times dt, which would be great if I had a deceleration. So let's make sure that we do. Ship.deceleration equals, should be the same. No, it should be slower. 100 pixels per second per second. Okay. So let's see. So we're going to move our velocity towards 0 at that rate. Let's try it. I don't see our velocity moving towards 0. Why is that? So our velocity here was 581.15. After I update, it's still 581.15. I don't know. Was it? Maybe. Did I use this thing correctly? Move towards, oh no, it's called move towards XY. That's right. It's a totally different version of the method. Okay, that's better. It should decelerate faster than that though. Maybe 500 pixels per second squared. Of course, it's making it harder to accelerate too. That's a pretty good acceleration rate. But I've gotten a little bit sluggish as far as, you know what, it's decelerating too fast. We're going to tweak this down a little bit. We're going to increase this. Yeah, that's pretty good. I also wonder if we should have a top speed. Probably should. Because right now, if I wanted to just keep holding down the up arrow, this thing will get stupidly fast. Of course, in a real game, you'd probably run into an asteroid before you ever got going this fast. But yeah, I think a top speed is a good idea. No, I'm not going to do that because it's 34 past already. We don't even have any asteroids. So enough with that thing. Let's get some asteroids going. Some rocks. Okay, so I need a rock class. And it's a new game sprite. And let's see. Well, there's a couple things that's funny about rocks. One is that they spin as they go. So rock.spin equals, well, we'll actually have to do that in the init method. Because every rock should have a different spin. So we're going to call super.init. Then we're going to do self.spin equals, let's see, this is going to be in degrees per second. So something like 360 times rand minus 0.5. And then in the update method, oh yeah, we also have to assign a sprite, don't we? An image. Self.image equals self.rocks. No, not self.rocks, images.rocks. With a type, and then the size. Size is always going to be 0 initially. So let's see, random times 3, 0. Okay. So that gets us an image, it gets us a spin. Now in the update method, we can do self.rotation equals self. This should be a function of time step. Self.rotation times plus self.spin times dt. And then we can do super.update dt. Okay, so let's create some rocks. Let's make a method to create a rock. And we'll just say rock equals new rock. Rock.x equals, I don't know, 960 times random. Rock.y equals 640 times random. Rock.init. That should do it. So for I in range 60 to 7, rock.make, and 4. Okay, cool. I should have given them a random velocity as well, though, huh? So let's do that. Rock.v.x equals random times minus 0.5 times, I don't know, 100 maybe? Same for y. They could go a little bit faster than that, I think. Yeah. Try 300. There we go. That looks like an asteroid field. Very cool. All right. I would have just died if we had collision detection, but we don't yet, so that's good. Okay. This is a little bit of an aside, but it's way too quiet in there, and I want to take and put in that sound that I posted to Discord earlier. So I have it here. Oh, that was interesting. I just heard a funny noise and I don't know what it was. It was probably Twitch. Okay, let's see. Actually, where we get our images would be a good place to prepare our sounds too. So we have bip and boop. I'm actually going to do it a little bit differently. I'm going to do bip boop as an array of sounds, new sound, so that it's easier for me to write code that plays them over and over. So we'll just call one bip boop 0 and the other bip boop 1. And then we need, well, actually, I know I said I was just going to make it an updatable, but yeah, we could still do that. Heartbeat doesn't need to be a class. Heartbeats is an object. Heartbeat.update equals function of dt. So how's a heartbeat going to work? It basically needs a next play time and heartbeat dot which will keep track of which of the two sounds we're playing, and this is when we're supposed to play it. So we can say if time is greater than self.next playtime, then bip boop self.which dot play. Oh, and we need an interval, because, well, we could just, I mean, ultimately the speed of the heartbeat is supposed to depend on how many asteroids are left. But again, I'm going to cut some corners here, see how much we can get done in an hour. So I'll just make it fixed for now. 0.75 seconds per beat. So that means self.next playtime is equal to time plus self.interval, and self.which equals not self.which. So that'll toggle between 0 and 1. So now if we add that to our update loop, heartbeat.update, I should pass in dt in case I decide I want to use it. Nice. Can you guys hear that? I bet you can. All right, cool. So what should we do next? Collision detection or shooting? I feel like shooting would be more fun to do that first. Otherwise, I'm just going to be dodging stuff and never able to shoot back. So for shooting, we need bullets. And we need a lot of bullets, so it should be a class. Bullet equals new game sprite. Bullet.image equals images dot, I called it bullet, right? Yep. That's all we need initially. Now, bullets also have to disappear after a while. So bullet.despawn time equals 0, and bullet.init is a function that will set self.despawn time equal to current time plus whatever we decide, half a second or something. Hey Flubflob, glad you could join us. You missed my variable called beep boop if you just tuned in. I figured you'd appreciate that. All right, and so in update, we better call super.init. So init's the same as everything else. And then bullet.update equals function of dt if, well, let's see. Yeah, if time is greater than self.despawn time, then we got to take ourselves out of the list on the sprite display. So display for.sprites.remove val, which is a method added by listutils, self. Otherwise, we can do the standard updating, super.update dt. So that looks like a decent bullet class. I need more labels in my ship update. So turn, thrust, apply friction, and also fire bullets. Let's see. I don't want to spew out a stream of bullets whenever the fire button is held, so I really need to tell when the fire button was pressed. So we're going to keep track of, let's see, ship.fire was pressed equals false. Okay, so here we can say fire is pressed equals function, no, key dot pressed, yeah. I'll just use a spacebar for now. So then we can say if fire is pressed and not self.fire was pressed, then spawn a new bullet. b.init, b.x equals self.x plus cosine radians. I'm just going to move it out in front of the ship a little bit. If this whole thing is, let's see, it would be 32 from the center to the edge, except that we've scaled down by half, so it's going to be 16. b.y equals self.y plus sine of radians times 16. Oh yeah, and then we should do self.fire was pressed equals fire is pressed. Okay, does that get us bullets? Let's find out. No bullets. Well, it kind of does. They're just not moving because we didn't give them any velocity. Okay. You know what? I want the init method to take... Actually, there's only one ship. No, that's not true. Because we're going to have UFO bullets eventually. That'll probably either be the same class or it'll be a subclass. So, fine, we'll just do it here. B dots. I'm trying to decide where I want to put this code to give the bullets some velocity. Well, we'll put it here. We can always refactor it later. So cosine radians times whatever the bullet velocity is, which I'm just going to hard code for now, because darn if I don't have only 15 minutes. Always sounds like a project I could do in an hour. I think, yeah, I could do that. It's not a complicated game, but you get into it, things take a little while. Like discovering that your bullets are way too slow. 500. That's more like it. Where'd I go? There I am. Oh, you can actually get out in front of your bullets. That's something I hadn't thought of. That's really interesting. Should we add our current velocity to the bullet velocity? I'm not actually sure if the original game did that or not. Or do we just make our bullets go faster? Into the infinite. Yeah, I'm not sure, but I think I'm going to try it. Self.v.x plus an additional 500 pixels per second. So, same for y. So now if I get going, the bullets at least always stay ahead of me. Okay. Yeah. Okay. So we have bullets. I think it's time for some collision detection. So bullets collide with asteroids. Asteroids collide with bullets or ship. Asteroids don't collide with each other, and bullets don't collide with the ship. We're probably not going to get to the UFO today. So let's start by making sure everything has a local bounds set. And we can do that. Let's see, the ship, we'll do it right here. Ship.local bounds equals new bounds. It needs a width, which for a ship is, let's see, 1, 2, 3, 4 times 16 is, that can't be right. Oh, yes, it can. Yeah, that's 64. But we're scaled down by a factor of 2. Oh, but careful now, local bounds takes scale into account. So we want to define the bounds using the same coordinate system as the images. So we'll say width is 64. Could you put that in the init function? I could, but I don't need to because it never changes. So it's fine to define it the same place we define the image and everything else. All right, and then the height for the local bounds is 32. That's for the ship. For a bullet, actually, I don't know if there's any point in having a bounds for the bullet. We could just treat bullets as a point, and that'll be more efficient anyways. Rocks definitely need it though. And with rocks, we're going to have to, we really need like a set size method, or maybe make that part of the init. So size equals 0, self.size equals size. Then we can do self.local bounds equals new bounds. And I have to do it this one in the init because different rocks will have different bounds. Local bounds dot width equals, and these things do not extend all the way to their edges. I'd say they extend, let's see, 1, 2, 3, 3/5 of the way, or 4/5, maybe 3/4. I'm gonna put in a fudge factor here. So that image.width times 75 height. We could fine tune that obviously with a little experimentation, but okay. So now everybody's got a local bound set. So the easiest place to check for rocks hitting the ship would be in the rock update method. So we'd say if self.worldBounds, actually we don't even have to say that. Sprites can check. I need my cheat sheet. I don't have the cheat sheet in my recent documents over there. It's embarrassing. All right, so manuscript, files, manuscript, micro cheat sheet. Here we go. Okay, sprites, overlaps. That's what I was looking for. So if, yep, if self.overlaps ship, then ship.destroy. And actually, I think the rock is supposed to be destroyed by this as well. Just about every kind of sprite has some sort of destroy function, so we're going to put that up here. Sprite.destroy equals function. Display for.sprites.remove val self. And then subclasses can override that as needed. And in fact, our bullet should just use that. I should just use self.destroy for when they run out of time. Okay, so let's see if rocks now cause the ship to disappear. Nope, not if I type overapps. They don't on line 124. Overlaps. There we go. Oh, I think I'm already gone. Yep, that's pretty good. Okay. That's a boring collision effect, of course, but hey, we'll improve it. First, though, let's make it so we can shoot rocks, because that's when it really starts to feel like asteroids. And that would be, let's see, should we have the bullets check for the rocks or have the rocks check for the bullets? I think it actually would be easier to have the rocks check for the bullets if we kept a list of bullets, which we can easily do. Bullet.instances equals a list, which we will push ourselves onto. Bullet.instances.push self. And then we need to override the destroy function. Okay, so the bullets. Bullet.destroy is going to do super.destroy, and then bullet.instances.remove val self. Okay, so now we have this list of all bullet instances. Shouldn't be too many, hopefully, and we can say else, if we haven't hit the ship, for b in bullet.instances, if self.contains b, then self.destroy. Yeah, that makes sense to me. So, of course, we're going to want destruction to be more interesting than just disappear. But if I can hit something, okay. Hey, that kind of worked. Did something disappear even after we did? No, I don't think so. I think we're okay. I think maybe my turn rate's a little too fast. I'm finding it hard to control. But it's kind of working. All right, let's get this more interesting. We need rocks when they destroy to make smaller rocks, if they're not too small already. So rock.destroy is a function. And it can do super.destroy, but then if self.size is less than 2, then break into 2 rocks of the next size down. So rock.make self.size plus 1. Do that twice. Oh, and I have to set the position. I'm going to pass that in as a second parameter. Self. Okay. So where is rock.make? That's down here. Function size equals 0 and position equals null. So we're going to pass size into the init method. And then on position, we're going to say if position, then rock.x equals position.x, position.y, else pick a random position. And always pick a random velocity. That might work. You guys buying this? Oh boy. Well, that's just peachy. Hey, cool. Yeah, my turn rate definitely feels a little off. Neat. All right, that's pretty cool. Let's see. We're getting low on time, but I want to make explosions a little more interesting. I think what we want is a little debris cloud, which is going to look just like the bullets, except that they won't actually hit anything. But we can use the same sprite. In fact, I'm going to come up here and say images.debris equals images.bullet. In case I ever change my mind, I can just change it here. And we need a debris class. Actually, yeah, no, we do need a debris class, darn. It's going to be a lot like bullet. And then it has a despawn time. let's see, I think I'm going to call it timed sprite. It's a game sprite that has a despawn time, and it's init sets the despawn time. Let's see, duration set to 0.5. So we can pass that in as a parameter. Destroy is fine the way it's defined in the base class. And the update method is going to do this. Yeah. Okay. And now we can make bullet a timed sprite. And the only difference is a bullet, its image is automatically set to images.bullet, and it keeps this instances array. So we don't need this. I'm going to explicitly pass in the duration for a bullet, and I'm also going to increase it a little bit while I'm at it. Destroy is fine. Update is no longer needed. Okay, so now we can make a debris cloud. Let's see where I want to put that method. Seems like it should come after the classes. Here we go. Make debris. Let's function position. Maybe that's all we need. For I in range 10, which is how many pieces of debris we're going to have. Let's see. D for debris equals new timed sprite. D.image equals images.debris. Let's give it a random. Oh, let's copy the position first. D.x equals post.x and D.y equals post.y. And then we'll give it a random velocity, which is going to look a lot like this. Except that it's D. And I better call a init, huh? Init. All right, so make debris. So let's do that when a rock is destroyed. Make debris self. And we'll also do it when the ship is destroyed. I don't think ship has a destruction method yet. Ship.destroy equals function. Super.destroy. So do all the standard stuff plus make debris self. Let's see. Can't set indexed element of null on line 85. 85 is right here. That probably means that V is null. What is going on? Oh. Do bullets no longer have a V? Or did we fail to initialize it? Maybe. Super.init, timesprite. Okay, yeah, timesprite init failed to call super.init. There we go. Hey, cool. Oh, that's pretty neat. All right. Well, alas, we're out of time. Once again, my eyes are bigger than my stomach, as my mother used to say. And I've bit off more than I can chew in 1 hour. But we have a pretty fun start on an Asteroids game here. I will post the code to GitHub because why not? Y'all can check it out. See if you're better at this game than I am, because I fairly suck at it. Yeah, I'm not good. But it's fun, and I like the look. The glowy vector graphics came out pretty nice, I think. Yeah, that's a refinement. At some point, you need to not start the player right on top of an asteroid. And I think the acceleration and deceleration could use a little tweaking too. And of course, we never got the UFO in there. And I didn't tint things like I said I was gonna. Let's do that real quick. Where's ship? Ship.tint equals lime. There we go. should probably tint the bullets line too. But anyway, I'm just stalling now. Thank you all for joining me. I really appreciate that you guys come by and hang out with me while I do these weekly challenges. If you're interested in seeing me wrap this up, let me know by Discord or, yeah, Discord's probably best. And if so, we could finish it next week. Otherwise, if you guys think you've seen enough and you want to move on, oh wait, we can't do it next week because next week is the Try It contest demos. So be sure to tune in next week. I'll be going over all of the Try It entries. And I haven't even looked at them yet myself, but I bet there's some pretty fun stuff in there. All right, so until next time, happy coding.